All right, guys. Radians and arc length. Here's some notes here, and I'm going to go ahead and do a couple problems in a minute, but I wanted to just help you understand where the formula comes from for um, arc length. All right. So right over here, we can see the circumference. This is circumference, right? And what does circumference mean? You might want to ask yourself real quick. If you can answer yourself, it'd be good. Okay. Circumference is the distance around the circle. Okay. In the exercises we're going to do, it's going to be asking us for arc length. Well, you're probably seen this formula by now. S, the arc length, equals the radius times whatever theta is, or the central angle. Okay. So this is arc length. In the picture I just gave you, or in this problem, can you see how the arc length over here is just this green portion right here? That's the arc length. So really, it's just a partial circumference, right? An arc length is just a partial circumference. So this is the arc length right here. Okay. Um, and I'm going to convince you here that these formulas are exactly the same, except for different situations. Circumference is for the length around the entire circle. Arc length is just for a little segment. Okay. So what you can see in circumference, it has a radius, doesn't it? Okay. This is the radius. And over here, we also, for arc length, it also has a radius. Okay. So now what are we left with? We're left with 2 pi. Over here, for circumference, 2 pi. Well, what's 2 pi, guys? 2 pi is the distance in radians around all circles. Okay. And over here for arc length, we have this theta here. Well, what's theta mean? Theta means central angle. Okay. Central angle, or, the measurement. And in this case, the central angle is 90 degrees. Okay. If you look here, central angle, I'll make another arrow here. That's this right here, right? It's 90 degrees. So do you see how everything goes together, right? How far am I going around this circle on the partial one? Only 90 degrees. Okay. Whereas in the complete circle, we're going all the way around. That's why that one says 2 pi. Okay. So hopefully that makes sense for you. So let me go ahead and I'm going to call these meters. Okay. Boom, boom. Right. Now, what do we notice first off before we even begin? On the first example, we're going to go all the way around the entire circle. Well, what about for the second? What about for this one right here, number 2? Let's just call these 1 and 2. So for number 2, how far around the circle am I going? We're going 90 degrees around the circle, right? Which is how far? Isn't that 1/4 of the way around the circle, right? So before we even begin and find the circumference for number 1 and the arc length for number 2, shouldn't number 2 be exactly 1/4 of 1, just in thinking about it? Okay. All right. So let's go ahead and find the circumference here. So circumference equals 2 times pi times the radius. So circumference equals 14 pi meters. Okay. That's the circumference around the entire circle. Now for this one, we're going for the arc length. Arc length, S, equals the radius, which is 7. They're the same exact size circles, right? With 7-meter radiuses. 7 times, now what's my central angle? Well, we need to turn my 90 degrees into radians, okay? I need my central angle to be in radians, and in this case, it says 90 degrees. So let's go ahead and turn it into radians, just like my circumference is. So 90 times, what was the converter? Remember, it's pi over 180 degrees, right? That's how we convert. So I'm going to get 90 degrees pi over 180 degrees, right? And what is 90 degrees over 180? That's just 1/2 pi, okay? And the degrees, remember the degrees cancel each other out. Boom. 90 over 180 is 1/2. So over here, my central angle is 1/2 pi. And what is 7 times 1/2, guys? Or what's 1/2 of 7? It's just 3.5, isn't it? So this is 3.5 pi. I wrote an M when I meant to write a pi. 3.5 pi meters. And just like we said earlier, the arc length of number 2 is exactly 1/4 of the circumference of the circle. Okay? All right, I'm hoping that that's helping you to understand a little bit more of arc length. All right? So let's go ahead and do a couple more problems here. Radians and arc length. Here we go. So here is the formula. S equals the radius times the central angle. So this one's going to be pretty straightforward. S equals, the radius is 6, and you can see that my central angle is already written in radians. So that makes life a little bit easier. So it's just 6 times 3 pi over 5. Multiplying fractions, this is 18 pi over 5. So this is 18. You could write it like this in Khan Academy whenever you put it in. Okay, that's how they're going to want you to write it. Cool? So that's the length of this arc. That's the length of S there. All right, next. These next two aren't, let's see. The next two are a little different. It says write a formula for S in terms of R. This is a little easier than you might think. So arc length is S. Does it give me the radius? It doesn't, right? It's just saying R. And then what's my central angle? In this case, it's just saying 1.2, okay? That's not degrees, by the way. That doesn't look like 1.2 degrees, does it to you guys? So what we can recognize, this 1.2 right here, this is in radians, okay? Would have to be, all right? Because that's definitely bigger than 1.2 degrees. And besides, it doesn't have a degree symbol on it. Okay, so I'm gonna switch the order of this formula. And this is what Khan Academy is looking for. It says write a formula for S in terms of R. And that's all it means is we've written a formula for S in terms of what happens to R. And what happens to R in this case, we multiply it by 1.2. So there's my formula for that one. All right, next. An arc subtends a central angle measuring 7 pi over 4 radians. The arc that they're talking about in this case is this big long arc right here. Boom. See this arc? Let me write a little arrow. Boom. Boom. That's the arc they're talking about. Okay, it goes all the way from here all the way around this circle, okay? To here. That's what they mean by an arc subtends a central angle. Now we can see that our central angle is measuring 7 pi over 4 radians. What fraction of the circumference is this arc? Well, guess what? It's a lot of it. How about that? Isn't it almost the whole circle? Okay. It's almost the whole circle, isn't it? So it's saying what fraction of the circumference is this arc? Take a guess right now. Is it is this arc 1/2 of the circumference? It's not, is it? It's bigger. It's way bigger than 1/2, right? Okay? Matter of fact, like 1/2 of the circle would be about that would be about this much, right? That would be about this little, that would be about that much of the arc, right? Okay. It's almost the whole circle. So I'm going to guess. No, I'm not going to guess. I'm going to let you guess. Is it bigger than 3/4 of the, is that arc bigger than 3/4 of the circumference? And you should say yes. Okay. 3/4 would be about like right here. This is like, let's see, 3/4 of the circle. Oops. Anyways, so we're going to go ahead and do the math. I'm going to do the math behind it, but I'm just trying to get you to estimate things, okay? So let me erase this. Boom, boom, boom. All right, so how do we find this? Well, guess what? It's telling me that this is 7 pi over 4 radians, right? Out of a total. It's not giving me the circumference, is it? Okay, but what do I know about how far around a circle in radians is the entire circle, right? Well, we've gone over this, right? It's 2 pi. So here's my fraction here, 7 pi over 4 over 2 pi. That's how far. So this is my arc, right? And this is the entire circle, right? This is the length around the entire circle, right? So I have 7 pi over 4 over 2 pi. Well, 7 pi over 4 over 2 pi is the same as divided by 2 pi. Okay? So I'm going to multiply it by the reciprocal. So what's the reciprocal of 2 pi? It's just 1 over 2 pi. So if I multiply across my numerators, I'm going to get 7 pi. If I multiply across my denominator, I'm going to get 8 pi. Boom. And then we can see that the pi's cancel out. So my fraction is 7/8. It's 7/8 of the circumference. That looks right, doesn't it? That arc, that red arc around the outside looks like 7/8 of the circle. This makes sense, okay? Hoping this video is very helpful for you guys.